Hello students. Now we will move to the small samples for two populations. So two population estimation with small sample sizes. Now our focus is on the main right now, and we have just finished with the estimation of differences between the two population means for large samples and z distribution we have used over there. Now when we go for small samples, small sample means both n1 and n2 are less than 30, sigma 1 and sigma 2 are not given or known. Further, we assume that data are approx normal. So we have two different applications to compare the difference between two population means. And regarding the population variances or standard deviations, we take assumptions and whether they have equal population standard deviations or variances, or the population standard deviations are not equal. So if these two are found equal, we go for an approach we call pool T, and if the two population variances or standard deviations are found different from each other, then we go for non-pool T approach to follow. Now you can see the equality or inequality of variance is a prerequisite to determine or to make a choice between the given two approaches. Therefore, we need to first look for the relationship between the two population variances. And for this purpose, we need to go for another distribution that we call F. Since F is comparing the variances of two populations, therefore, we need to recall which distribution we have used for estimating one population variance, and that's chi-square distribution. So since we are comparing two population variances now, then we need to consider two chi-squares, chi1 square and chi2 square. These two are again connected in the form of ratio. We know that chi-square has this formula, n minus 1 times s square divided by sigma square. Therefore, we make a substitution in place of chi1 square and chi2 squares like this. Now we first look into this. If we can control this by taking both the sample sizes taken out from two different populations equal, therefore this will have no significant effect because the ratio will be equal to 1. Even if we take closer number of observations from two sample data, therefore even in that case, this ratio will have no significant effect on the remaining part of the ratio or remaining terms. Therefore, we can simply ignore this component from the formula, and consequently we end up with this ratio that we can further rewrite down in this way: s1 squared divided by s2 squared times sigma 2 squared divided by sigma 1 squared. Over here, you can take notice of one thing, that sample variances are connected in the form of ratio of 1 is to 2, whereas the population variances are mentioned as 2 is to 1 ratio. This thing you need to consider or remember always. Now, since F distribution is originated from 2 chi-square distribution, therefore it will have the similar characteristics as chi-square have. Now, what if we take 1 minus alpha percent CI limits? So the norm is the same what we have followed in case of chi-square. The upper bound of chi-square must be indicated as chi-square with alpha by 2, we all know. So similarly, F ratio or the upper bound of F statistic for 1 minus alpha percent should be indicated in the same way. Furthermore, we need to indicate the degrees of freedom nu1 and nu2. What degrees of freedom are? Nu1 is simply equal to n1 minus 1, whereas nu2 is equal to n2 minus 1. Now similar to chi-square, the lower bound is indicated as 1 minus alpha by 2 subscript, following the concept of 1, which is the total area, take away the area below this borderline of alpha by 2. So 1 minus alpha by 2, nu1 and nu2. This is how we indicate. Now, we can write this down as usual in the probability form, that this sketch is representing the two border lines that covers the area of 1 minus alpha by 2 in between the two. So this is how we write down or specify the existence of f within the curve. Now, what we do, as usual, we take the central part inside the probability specification as this. Now we substitute the value of f in the center of this Ci as s1 squared divided by s2 squared times sigma 2 squared divided by sigma 1 squared. If we take notice of the ratio of population variances here in the center, it is in the order of 1 is to 2, and we prefer it to write it down in 1 is to 2 order rather. Therefore, what we can do, we can take reciprocal of the entire inequality. This is how we get the lower bound adjusted accordingly, and the inequality signs will also be adjusted. And this ratio will become s2 square is to s1 square accordingly. Now we will move this factor from the center. To remove this from the center, we need to work with the multiplicative inverse of this, and we multiply entire inequality by the reciprocal of this factor, and this is how we get this to be mentioned on the left hand side in this way, and we will be left with only the ratio of population variances right there in the center. Similarly, this is how we do it on the left hand side as well. And since we have a law to write down lower bound first and then the upper bound, so lower bound is this factor, whereas upper bound is this one. So we make adjustment in the CI factors accordingly. This structure is still not usable because if we refer F table, in the F table we can get the probability of alpha by 2, but we cannot get probability of 1 minus alpha by 2 same as chi-square table. In the chi-square table you can recall when we are constructing 90% CI, so we get the two bounds as f chi-square 0.05 and chi-square 1 minus 0.05, that gives you 0.95. But in the F table, we are not given 1 minus alpha by 2 part. That is, we are given 0.05 but not given 0.95. But there is a relationship between 0.95 and 0.05 or alpha by 2 or 1 minus alpha by 2, and that relationship is that f 1 minus alpha by 2 nu 1 nu 2 can be approximated with the reciprocal of f alpha by 2 nu 2 nu 1. Over here you can take notice of one thing, that 1 minus alpha by 2 is only replaced with f alpha by 2 if we take reciprocal. Furthermore, nu 1 nu 2 should be reversed in order as nu 2 nu 1. This is what we need to do. And similarly, since this left hand part in the inequality is in the denominator, therefore we need to take reciprocal so that we can directly make a substitution in its place. So if we take reciprocal on the left hand side, we need to take reciprocal on the right hand side as well. Now in place of this term or this factor, we can simply substitute this. So we can now rewrite down formula in this way. Nothing will be changed on the left hand side or the lower bound of the inequality, but in the upper bound this s1 square to s2 square ratio remains same, but this should be written as f alpha by 2 nu 2 and nu 1. This is how we can derive the formula for 1 minus alpha percent Ci for the ratio of two population variances. And we will now be applying this formula to discuss the question regarding pool T application and non-pool T application one by one. That's all from this part of the session.